one of the guys that made a huge amount of money was one of the janitors, because the early pick and place machines and the early tape and reel was made out of paper, and the tape and the reel out of paper particularly didn't do well in various types of humidity. And so you had this phenomena where, you'd start to peel off tape on the tape and reel, and instead of one component being presented, you'd have 3 or 4 dozen. And the standing joke was anytime some of us were allowed to assess different factories, the first thing we would do is walk up to the pick and place machine, look into the bow of it, and see how many components were down in the bottom there. Anyway, there were a handful of janitors that would sweep them up and repackage them and retest them and resell them, and got themselves a new pension fund.
Welcome to the Decode Podcast. We are back tonight with our special guest, Mr. Phil Marcoux. Joining as well, as always, Sean Kincaid from K&F Electronics and Mr. Daniel Stamfil from Aurora Boardworks. And I am Elias Malfavon with Metal Edge Services. Phil, welcome aboard. I have your title down as retired, but I also have LOL in parentheses next to it because you seem to kind of be pretty active for a retired guy.
He's working more than most people I know.
I usually try to get a little bit of info together to present a little bit of a bio of our guest, but I think I can pretty much sum it up in one line. You were named the father of surface mount technology in North America by the IPC in 2007. So, I mean, that's probably saying enough, but I also wanted to highlight that you're authored over 200 technical papers, articles, and business plan. You're named as an inventor in 6 patents and a co-owner of over 40 patents in semiconductor packaging and assembly. How much time do we guys have, guys? Because I got a lot more.
That's plenty. That's plenty.
The only other thing I want to point out is that although you're very storied in the industry and a true pioneer and retired, you haven't let that stop your kind of forward progress in the industry. And I wanted to highlight that you were the group leader for AI in the electronics industry with PCEA, looking at implementing AI and in the electronics world. So obviously you're still very up to speed with what's going on. So that's my intro. Welcome aboard.
You'll be speaking on the topic at PCB West even, right, Phil?
Well, actually, I'm organizing a couple of true experts to come and talk. A couple of guys that started 2 companies doing work in the area for new product introduction. I mean, this last stint, you say that I've decided finally that, retirement is really, at the age of 80, I've decided it's about time I really ought to start thinking about slowing down. This last stint where I agreed to be general manager for this company, Epoch, taught me a great deal about how much has changed in the surface mount area and how little has changed in the surface mount area. One of the depressing things that has changed very little is how much design engineers mind their P's and Q's and dot the I's when it comes to presenting new products to assemblers like us and Sean and you folks with your stencils and the like. And designers don't appreciate the fact that you save their tushes a great deal. There was, a number of stories we can tell, as I'm sure you can tell as well. So I've decided to start to focus on applying some of the tools that are available now with AI and some advancements in the manufacturing tools, as well as encourage people to enlist those for better communication to help provide education and more support for the designers. I mean, there's a lot of turnover, so we can't slight them for the fact that they don't have, a lot of bench depth when it comes to knowing how to present their products for manufacturing. And the more we can do to help support them and make it easier for them and ourselves, the better. So anyway, for this session for PCB West, I spoke with Mike Buteau, and he said, "Oh, geez, we desperately need this." So anyway, I'm going to start this effort to present tools and companies helping with new product introductions. So yes. Other than that, the other effort we have going, my wife and I have reached a point where we've sort of turned the page to another new give back effort. We just launched a couple of scholarship funds, so we're starting to give back some of the financial areas we've accumulated and benefited from, and use those to benefit other folks, primarily encouraging people to go into engineering and nursing and education. And so we just launched those. We actually launched it a week ago, and we already have 55 applications for
Wow.
the scholarships. Yeah, so we're pretty excited about that.
That
So other than that, we've been cooking a lot of bacon for the folks who visited us from Scotland. That, and turned out they were gluten-free, gluten intolerant, and so we had to find out gluten-free flour and make them oodles and oodles of waffles. So in addition to the bacon, they love waffles. Also, I will alert you, there's probably a shortage of maple syrup here on the West Coast too.
So,
You,
so
you
there
know,
you go.
gluten-free can actually be kind of tasty sometimes. My friend's a vegan,
Well,
and it's not bad. It
maybe in
deserves
waffles, not in
Yeah.
noodles. I'll tell you, not in noodles.
Were they good though? Were they like kind of
Oh, the
waffly?
waffles, yeah, the waffles were great.
Yeah.
The noodle dishes, they can, we can leave those.
So you heard it here. If you want the secret to making it to 80 and still being able to get out in a kayak, plenty of bacon and maple syrup.
There you go.
That's
You know,
right. Yeah,
Phil-
actually, I took them kayaking, and I went kayaking yesterday myself. So, yeah.
You know, it's funny you say that about the PCB designers because since the last time I showed you my internal program, it's grown up a little bit, we'll put it that way. And it generated this report. I'm using it more of implementing my problems and how could we have caught this at the quoting stage and prevented this from even reaching the floor, alerting the customer ahead of time, hey, we should change this and this. Some of it's simple, like we ran a job that had extremely small apertures. I forget the pitch, at least I don't know if you remember what it was, but we ended up finding out that it was a 2019 stencil, customer supplied, and it was a 5 mil non-nano coat. And with that like pitch, you just the AR on it was just awful. And
With nano coat or without?
without nano coat, 5 mil. And Elias, do you remember that one? I know I've sent you a couple.
I think it was like 0.57 AR or something to that effect at 5 mil.
Yeah, it was borderline of like and I was getting bridging and clogging of apertures, so it was like telltale. Anyways, I'm feeding that in. So I'm running this one for this other customer recently, and it's looking at the data sheets, looking at the pad lands, and it finds that it's not centered correctly. The designer designed it wrong. So we send that over to the PCB designer, and they're like, "Oh, we'll change that on the next revision. Let's just run this way because you've been doing it for so long." And I'm like, well, we have new information now, like we can change this now. We're about to have the boards built. Like we can change this, and it's not even a big jump. And I was able to show them too, even with like the AOI data, the images of, because this is designed a little bit off center and short, that the heel of the actual solder joint is not getting soldered. Like it's barely getting solder on there. And I went through this whole IPC, but it was almost like I was stonewalled And what am I gonna say at some point? I'm the one I need the PO. I want the PO, so I gotta
Right.
do it,
Yeah.
and I
Yeah,
know
like
it works, right?
got you over the barrel. Yeah.
Well,
So
I mean,
yeah,
even according to IPC standards, I mean, their wish trumps IPC standards. Like the
it does.
customer requirements are greater than the IPC standard requirements. So, I mean, if they say send it, like, I mean, that's what they want you to do, right?
Yeah.
Yeah, and I can't.
Well,
I
that's
feel awkward saying to him like, "Hey, if this goes wrong, you're legally liable." Like I'm not gonna say that to him, but like I want to almost in a sense.
Well, you're trying to help them on the front end,
I
avoid the
am.
problem, and they're just like, nah, we're good.
Yeah.
yeah. Well, let's use this story to segue into what I'm concerned about as far as the emerging environment of, your EMS business. You're going to be have a difficult time hiring enough people to do DFM analysis for this type of customer. I mean, really, one of the things we should be in a position to do is provide DFM analysis coming in the door on every design before you even let it go into PO stage. This company Epoch that I was with, I mean, they had the benefit of having a large large talent of engineers in China supporting, because of the communication setup that we had, supporting any product that came into the facility that I was managing here in San Jose. So, I mean, all the DFM was done, well, because of the time change, could be done the night before we even started to order stencils and touched any of the incoming boards and materials. But we also were not a facility, particularly here in San Jose, that could even attempt to hire somebody to do that on a human basis. Here, I mean, it had to take advantage of an area such as China, and now their other facility they're setting up in Bangalore, India, to be able to have lower cost talent, even though they were quite capable and exceedingly skilled, but lower cost to where we could actually afford to provide that service. I think one of the exciting areas with some of the AI tools that are coming out is the fact that small EMS companies here stateside can still provide DFM type services to customers on an advanced basis. The key is the designer's got to be comfortable to want to use it. Now, from what I've learned, both directly in working with customers last year, as well as continuing my involvement with PCEA, the community is frankly afraid of AI. And in some respects they should be. In other respects, it's a shame that they are. It's inevitable, and I think once they understand the benefits, they'll become much more comfortable. The AI that we, Sean and his facility and us at Epoch when I was there and other EMS companies are using is what we would call predictive AI, meaning, it's using tools and algorithms that have existed for decades, but we're just expanding the database so we have more intelligent data to draw upon to make conclusions and estimate trends and provide answers for manufacturing type of solutions. The area that is really more new is this generative AI, which to me is exciting from the standpoint of is improving communications. So, the DFM type part of the equation can certainly draw upon benefits from the generative AI applications. ChatGPT is one of those. As an example, yesterday I had a interview with a company talking about a real estate project, and afterwards they sent me entire transcript of everything that was communicated amongst all the members in the meeting, as well as a video of everything. So, I mean, for someone in the EMS area, like like the story you were just talking about, Sean, you don't want to accuse, or you don't want to be too threatening to the customer, but by the same token, they got to be put on notice that they're going to be liable for the board defects that may occur. Now, of course, they're going to fight you tooth and nail, but at least with a tool like these AI transcribers, at least you'll have some record to say, wait a minute, I alerted you to this, you accepted liability, so let's take and assume the liability where it should be assumed. So that's really the genesis of that project that PCB West has, and what I think is the exciting areas that are developing in AI. I'm hoping that PCEA plus yourselves, the effort, the effort you guys are doing is just outstanding. It's so beneficial for the industry. I'm just hoping that this helps reduce the fears and apprehensions that, our industry has towards using the tools that are readily becoming available. I was excited, Sean, to see that you're using Luminovo for supply chain services. There's a number of other similar. The fellow that's going to be presenting at my PCB West session is Rajesh, who's co-founder of a similar company called Whizzer. They tend to focus on a more narrower area of supply chain services and finding than what Luminovo, but nonetheless, very, very exciting as to what benefits that has for you as an EMS company and certainly as a designer. Cripes, now designers should be able to come in. I'm sad to say there's one project when I walked in the door of Epoch January of last year, the boards had been sitting there for a good 6 months because they were missing one component. When I left there in December, the boards were still sitting there waiting for that one component. So,
Doesn't matter how good your design is if you can't finish it, right?
Yeah. And of course, the customer doesn't realize that, those boards are sitting there without rent-free. And of course, the EMS company, who still has to pay people to walk by and inventory those, receive no income whatsoever. And if there's a fire, God forbid there's a fire or water damage or something in the facility, of course, the customer is going to hold the EMS supplier liable for that. It's unfortunate, but hopefully the tools that we're seeing emerging will help alleviate that, and efforts like PCEA and yourselves to provide better training will help alleviate that.
And software like that's becoming even more critical because I don't know if you've seen it, Sean, if you're experiencing it, but we're starting to see similar stuff to around COVID time with the supply chain. There are some components that are starting to get pushed out crazy far again, where you're just seeing imaginary lead times basically on some of them, where they just pick a date and throw it out there.
Right.
And it's bare material. The materials for the substrates are getting harder to source for the fabricators, and everywhere it's kind of getting squeezed right now. It feels like
3 of the 9 quotes I sent out today, I seen 23-week, 27-week, and 29-week lead time, and it was just one part on each of them.
Wow.
You know what I'm saying? And the worst part was it was non-cancel, returnable, right? So if we're locking in, we're locking in, guys. Right?
You own it.
There's a back order. There's a back order. There's nothing we can do about this.
Bill, I want to jump in real quick and kind of switch gears, and we can definitely get back to AI related conversations. But if we get through this episode without me touching on this, I won't forgive myself. So we had the pleasure of interviewing you. I think, was it Apex 20?
It was our first Apex.
Yeah, Apex 25. And obviously having the name of the father of SMT, there's some history there, and we got to start to touch on that history, and particularly the birth of surface mount technology. And surprising to me was that there was some plight associated with that. It wasn't okay, here's this new technology, everybody loves it. And I'm not meaning to put words in your mouth, but I think I remember you saying something like there was some significant headwinds, particularly from the the military applications standpoint, and we didn't have all that much time to speak about that. So I'm wondering if you can kind of bring us back to that conversation and fill us in a little bit about that.
Yeah, yeah. The memory of that is still, sadly, quite vivid. I think I had my partner and I both had our houses mortgaged to support this facility, and we thought we were rocking and rolling, doing quite well. And then all of a sudden, orders dried up. This was in, as I recall, mid 1984. And we had received orders from some of the defense contractors. And then in the fall of 1984, the orders stopped, and then we didn't really have any clear answer, nor did they have any clear answer as to why. Anyway, I got a call from a fellow named Dieter Bergman, who many of you may remember from IPC days,
IPC Hall of
who
Famer.
said, exactly. And he said, "Hey, we're putting together this group because the U.S. military has put a ban on surface mount components." And so between the IPC and an organization called the EIA and one other one, they designated 25 C-level executives and asked if they would volunteer their time to come together and try and help advise the different government organizations that had put a stop on SMT. And so I agreed. Out here, a fellow named Winston Chen, who was president of Selectron at the time, agreed. Forget who else. Anyway, I remember all flying out to Washington, D.C. and sitting in a room that was filled with all sorts of people that wear suits and ties and, things that, you see in pictures that we don't see anywhere else anymore. And it was a pretty tense meeting. And we went around the room introducing various people. And I remember the guy sitting beside me was a fellow named Ed Westcott. I will always remember Ed Westcott. And he introduced himself as the CTO of the U.S. Air Force. I'm thinking, I didn't even know that the Air Force had a CTO. And he said, "I need to apologize to all of you because I'm probably the reason you guys are in this room. And the reason is I put out, I forget what the name. I know in the Navy they call it IDEP alerts. I don't know what the U.S. Air Force was, but it was a bigger deal than this. It was the entire Department of Defense. He said, "We put a notice out that all surface mount parts are suspect." And he didn't elaborate, but he said, "We've had issues where some of these little parts that you put on these boards seem to fall off at unfortunate occasions in airplanes." And he didn't elaborate, but he said, "We deem that serious enough that we put a stop to all use of these components. So unless you guys want us to use this technology, you're going to have to come up with some way to convince us that this is reliable." And I know GE agreed to be a big supporter and put in a huge amount of goodwill effort to help run the experiments necessary to show what the problem was. We discovered there were two main problems. One was the passive components at the time did not have a passivation on them to prevent what was called leaching. And so the solder terminations or solder would basically leach all of the terminations off of particularly multi-layer capacitors. So
it would just like lose its conductivity. It would just
worse than lose its conductivity. I mean, it would literally scavenge all of the metal off the terminations, and then when you turn the board over or vibrate them, the parts would fall off.
Because it's the metal that's
gone. Yeah. Wow. The other problem we had was there was a type of ceramic packaging called LCCs, leadless chip carriers, and they had a termination called a castellation, metallization on the side, and then they also had very large, ceramic areas. The castellations were not particularly strong and secure, And the ceramic also was a very stable, had a very low coefficient of thermal expansion, whereas the boards we were mounting them on had a very large, coefficient of thermal expansion. I seem to remember numbers for the boards being in the 22 and 24 part per million range, and ceramic is like 3. So here you were mounting the equivalent of the Rock of Gibraltar on, squishy marshmallows, and the castellations were union castellations, and at some point they said, "Hey, I'm reading my union contract, and this exceeds that union contract." So they would break.
Well, yeah, we used to work with a lot of ceramic, and if you even look at it wrong, it starts to, it's so brittle. It breaks so easily until you get it coated or encapsulated with something else to protect it from itself. But the thermal qualities obviously are huge. But yeah, you can see how mixing materials like that in that application
Yeah.
was prone to lead to failure.
Right. So anyway, what the outcome was, we very, thanks again to GE, and I think the Phillips National Lab was a big contributor as well. They discovered putting a nickel barrier on the passive components, prevented the scavenging of the metal. And then as far as the ceramic, I mean, the effort there was led by a fellow named Warner Engelmeyer, who helped everybody understand the mismatch of coefficient of thermal expansion, as well as the solder properties, because of the creep aspects of solder. Anyway, there we were able to use a underfill epoxy to help sort of stabilize the board in the immediate area around the big ceramic. And then we also, started to abandon ceramic and moved more towards, abandon the castellations and moved more towards lead frame type of packages. So it took, I guess it took about a year for things to recover, thankfully. But yeah, it was tense times for surface mount.
It's hard to imagine how different today would be had that effort not been successful. I mean,
Well, I think it would. I mean, I think it would have happened eventually, but just under a different timing and format. Maybe it wouldn't have been led by the defense industry in the U.S. Maybe it would have been ultimately. Well, actually, surface mount really didn't take off until it got absorbed in the laptop computers. I mean, the whole reason my first company got acquired was, IBM wanted to move into a laptop and they needed surface mount, and they told the subcontractor that was their main subcontractor, "Hey, these guys got the technology. They seem to know what they're doing. Why don't you just go buy them?"
so
They
Was
did.
that awkward? Was that awkward for you to sell back then, or was it an opportunity
Well,
offer you couldn't refuse type of thing, or what?
it was awkward because I wasn't ready to sell, and my
Right.
two partners basically said there's an old joke that I learned in my last company, because I got funding from a fellow who was a Dutchman. He taught me the story of how copper wire was invented. It was basically two Dutchmen fighting over a penny. And in the case of my first company, I did not want to sell, but the primary, the one largest equity partner that we had did want to, and he and I got into a fight over a penny a share. So my partners, we were negotiating on the top floor of a high rise here in Cupertino, California. And anyway, they showed me the window and said, "You can either, sign on this side of the window or the other side of the window." So.
did you see as SMT became more mainstream, let's say early 1990s, mid 1990s, did you see through-hole technology sticking around as long as it has?
Well, yeah, I mean, we had to. I mean, the ability to get surface mount parts for all components was exceedingly difficult. I mean, you think you got supply chain problems now? Holy cripes! I mean, it was egregious back then. I mean, we were even cutting leads on through-hole parts to make them pretend to be surface mount parts. No, I mean, I was glad that through-hole stayed around. Now you have to realize how I came into the surface mount world was through a company called Signetics, and Signetics, which ultimately became part of Philips, had uh, because of joint efforts in some of the European partners, come up with a type of reduced size package called an SO, which at the time was called Swiss Outline. A lot of people don't realize that one of the original meanings of the SO acronym was Swiss Outline, because the package was originally destined to be used in electronic watches. But that was a very slow, I mean, you think we have customers moving slow. Apparently the watch industry doesn't quite move as fast as their second hands. Anyway, they were moving too slow, and a fellow named Mike Crawley, who really is the fellow that we need to remember as being the true deliverer of the surface mount parts, was brought over from Europe to Signetics, which is located in Sunnyvale, close to me here where I was working. And he said, as a favor to this joint effort for Philips, I promised that I'd show you these guys these packages and see if you get excited about them. And he threw a handful of parts onto a table. Now these had little tiny legs. They weren't gull winged like we have now, and they had little legs, and they were intended to be 30 through hole parts. And I think the pitch was like 30 mils, which nobody, all the board guys said, no, there's no way we're going to drill these holes. Anyway, he threw them on the table, and a couple of us got excited about them. And one fellow, a fellow named Joe Resendez, who ultimately wrote the first paper that I can remember on how to do reflow soldering, picked up one of the parts and squished it down and bent the leads. And we think that's where the idea of the gold lead came about. He said, well, maybe if we just put them on the surface of the board, that'll do it. Anyway, getting the management of Signetics and Philips to agree to spend the money necessary for the molds and the newer lead frames and the trimming and the testing, I mean, the myriad of things that had to come into play in order to bring a package like the SO into existence was massive. And of course, I was in a management position where, like Sean just mentioned, he's got to put his whole company on the line for 27-week lead times. I mean, the amount that we had to put on the line for this family of little funny packages was horrendous. And of course, we shopped them around, and in the U.S., very, very slow, very low acceptance. It turned out it was a company called Mitel in Canada who actually placed the first orders for SOICs. And a handful of us were, and little side funny note, the official name of Mitel, any of you know Mitel is a telecom company? They were one of the first telecom companies. Anyway, the official name for Mitel is Terry and Ed's Lawnmower Company. And they were located in, of course it is, and they were located in Ottawa, Canada, and a handful of us would fly back and forth to help them. I mean, we were carrying boxes of tissues, Kleenexes. If these guys got sniffles, we were there to, dab their noses to keep them happy buying these, because we needed somebody to buy these handful of surface mount parts. And they were the guys that launched the beachhead for surface mount parts.
That's amazing, because I can't imagine a design today without one on there. It makes me want to go to my shop and just start stepping on diodes and LEDs and see if I can make something out of it like that guy did. Too funny.
Well, as another, if you're into side stories, one of the guys that made a huge amount of money out of Delco, which was the electronic supplier for GM, which is located in Kokomo. one of the guys that made a huge amount of money was one of the janitors, because the early pick and place machines and the early tape and reel was made out of paper, and didn't particularly, and the tape and the reel out of paper particularly didn't do well in various types of humidity. And of course, if you've been in Kokomo, Indiana, particularly anytime there's a tornado or the like, you know that they go from periods of dry to periods of wet, and the tape and reel didn't particularly last very well. And so you had this phenomena where, you'd start to peel off tape on the tape and reel, and instead of one component being presented, you'd have 3 or 4 dozen. And the standing joke was, anytime some of us were allowed to assess different factories, the first thing we would do is walk up to the pick and place machine, look into the bow of it, and see how many components were down in the bottom there. Anyway, there were a handful of janitors that would sweep them up and repackage them and retest them and resell them, and got
Wow.
themselves a new pension fund.
One of the coolest stories I think I've heard from you, and I've, don't get me wrong, the White House Council thing's awesome, but just the visual story that like I was picturing in my head when you talked about when you seen one of the first Fuji, basically the first pick and place machine, I want to say, in the world. And I think you were talking about how like they were manufacturing boats, propellers there.
Oh
or
no,
something?
props of propellers for
Yeah,
huge ships. Yeah, God, we walked into this facility. Well, first off, to get into the facility, I ended up hiring a Japanese fellow, because the Japanese companies did not want to sell any of this equipment to anybody in the U.S. So I hired a Japanese fellow, and he actually, quite interesting story on his part. Japan had a period where they had more kids to go to school than schools. And so they came up with this clever student exchange program. And it turned out it was a one-way exchange program. So his family was notified, oh, congratulations, you've been awarded a scholarship to go to school in Germany. And so he went off to high school for 4 years in Germany. And of course, nobody from Germany came to Japan, but he ended up, graduating, called his family and said, okay, I'm ready to come back and go to college. And they presented his credentials, and they said, no, we don't recognize high school credentials from any place outside of Japan. So you're going to have to go to another 4 years. And he ended up coming to the U.S. and somehow, I still haven't figured this out, somehow he got drafted in the U.S. Army and served time in Vietnam, and then actually ended up going to West Point. So he actually was a graduate of West Point. So he turned out he had quite a chip on his shoulder about Japan. So when I said, I need help getting into Japan, he said, I know how to do this, and I will help you. So
I'm your man.
Exactly. And he managed to get us into not only see the first Fuji equipment, but one of the other ones, which has gone by the wayside. But anyway, Fuji at the time, the pick and place machine was truly a skunkworks effort for a handful of engineers at the Fuji factory, because their main, from what I could tell, based on the facility we walked through, their main business was making props for ships. I mean, we're talking 2-3 story type of props. I mean, these things were massive. And I remember walking way in the bowels of this factory and just being in awe of the props and the spindles that held these things and the like. And finally getting to this back dark area, and the guy that presented the equipment, the Fuji equipment, it was obvious he was so excited about the fact that he had come up with a unique way of putting down a glue dot. He showed me, it looked like, Dairy Queen with a little twirl on the cup. Yeah, well, he came up with that design for putting glue on boards, so that he could glue components onto the bottom of the board and then run them through the wave solder. These were all wave soldered. The pick and place machine they came up with was basically a Gatling gun. it would just pummel boards at, at a rate of, oh God, I forget. It was like over 100,000 an hour type of rate. I mean, just pummeled these things. And of course, everyone, was nicely seated in this curly queue of glue.
So they were
Was that
surface mount components were being placed in glue, and then you were wave soldering the surface mount components.
Yes, and actually, the other company we visited in Japan, rather than use the rotary presentation of components, which Fuji was famous for, this other company worked with Philips, and Philips was literally using umbilical cords, and they had people standing on gantries, two-story gantries, dumping buckets of components into other buckets, and they were being fed with umbilical cords down into platens, and the components would sit into the platen, and then they would be all presented in mass up
Oh
to
my
the bottom
gosh.
of the board, and then the glue would hold the components in place, and then the glue would set and go over the wave solder. So they had the Gatling gun approach, and they had the umbilical cord approach.
Did
That
that
is
Fuji machine have a moving table underneath the head, or did the head move in the
The head's
X and
moved. Yeah,
Y?
the head's moved. Yeah, head's moved.
It's funny, Phil, because one of the earliest conversations the three of us here had was, I don't know why, but it came up, but I was telling them about epoxy stencils or glue stencils.
Yeah, this has
Used.
always been a
Yeah, I said, yeah, you find the center point of the component, and you can screen print a little bit of glue, and then you can run it through the wave with the rest of your through hole stuff. They says, no, you can't. You can't wave solder through hole component or surface mount components. I said, no, it happens still where there's might have an assembly where there's a few surface mount components. It's primarily all through hole. So why go through dual processes, right? Messing around with the screen printer and everything else, reflow oven. But yeah, they didn't believe me. So here, you guys heard it from the man himself.
It's true. It's true.
It's a thing, and it was
Yeah,
the first thing.
I thought he was crazy when he told us that because
Well, even crazier, the umbilical cord approach used a type of component for resistors and capacitors that we commonly called a MELF.
the rolling ones.
Roly polies.
Yeah, do you know what roly
No.
polies are? They're the inner guts of the regular axial leaded resistors and capacitors. If you leave off the outer coating and leave off the terminations, that's the inner guts.
Really?
That's where a MELF comes from.
electro leadless face. Is that what a
That's
MELF
a true
is?
leadless face. Yeah, that's where those came from.
Real pain in the tail, I call them.
Yeah.
I got one customer that uses them for spacers and I keep trying to, I like tell them, Liz, can we please use a resistor? And their pad design, they designed it looking at a stencil, I think, because it's not like it's not a home plate shape, but it's kind of like a home plate shape. I don't know how to describe it. And then they just seat them on these edges, and it's just a nightmare to get this thing to not roll sometimes. It's just
Well,
not a
interestingly
face.
enough, one of the guys that worked for me came up with what we call the horseshoe pattern, land patterns.
Kind of cradle it.
Yeah, to cradle it. And that was one of the, one of the other stories is just the creation of the IPC 782, the land patterns. I mean, that was another fight. And it was, again, thanks to Dieter Bergman basically calling all our bluffs, because at the time we thought that was the family jewels. We would tell people that, geez, if you don't use our land patterns, there's no way we can guarantee that, we're ever going to be able to assemble these. And God forbid you take them somewhere else. So, I mean, we all collectively, we couldn't fix prices. So obviously we said the land patterns were unique. And it was Dieter that just called our bluff and called us into a room and said, look, if you guys are going to get this technology going and get designers to embrace it, you got to come up with some better common design guidelines and standards. And this unique land pattern stuff is not doing you any favors. And so we agreed to work collectively and come up with the IPC 782. And as a favor to this fellow that came up with the cradle, I fought like crazy to try to keep that in the document. But of course, it got swept by the wayside. So
Having worked on a lot of assembly now over the past few years and seen all the different component types, to me it seems like we could do well to go back to a standardization of everything. Like, it seems like people designing components now are trying almost for no other reason than just to be unique with the footprints they're coming up with all the different bottom terminations and exotic patterns that are on the bottom of BGAs and everything. It's like, do they really serve enough of a purpose to go through all the hassle of how unique and crazy they all are? And honestly, like for DFM purposes, so you're talking all these different component manufacturers, it seems like none of them talk to each other about what a good standard is, or you look at the data sheets for what a recommended land size or stencil strategy is, and everything's just in conflict. You can end up with so much variance on the same components, even with the standards that exist.
Well, it's possibly because, the semiconductor guys, I mean, when I was in the semiconductor world, second sourcing various components was a requirement. And anytime we could come up with a component that didn't require second sourcing, boy, I mean, we celebrated. So it could be that they're utilizing that as a means to try to avoid second sourcing and having to give up part of their orders to other customers or other vendors.
Yeah, that's a pretty sharp piece of insight there, right? If you can make something so unique that it's not available elsewhere, you get it all.
Right.
Yeah, I seen this one yesterday and it kind of just blew my mind. I wish I could show you guys right now. It was like 12 lines, but it was some were diagonal and some are vertical and some are on the edges and some is in the middle and some
Did
are
it
longer.
QFN?
It's, I don't know. No, it's not I don't know. I'd have to look at like what the package officially name was, but I remember I pulled it up on the viewer and I'm looking at this thing and I'm like, what is this device? Like, this makes no sense, And then on top of that, like, it's all bottom terminated, right? Like, there's no, to fix this thing is going to be a real problem if there's an issue,
Have you gotten into flip chips at all? Mounting flip chips? Basically, parts without packages, they're just bumps on the chip itself.
No.
Oh, you haven't? Okay. Because they, what about Chicklets? Have you heard anything? Have you heard the term Chicklets?
I know Chicklets, the gum. I used to have that as a kid.
Actually, that's funny. You should say that. That's where the term Chicklets comes from.
Okay.
But Chicklets, I mean, the other reason that I got excited about surface mount was the idea of coming up with an alternative way to build what are called hybrid circuits. My background in semiconductors was in the analog world, data acquisition, and we needed lots of varieties of different chips. We wanted to mingle together operational amplifiers and voltage regulators and data registers, and things that weren't compatible with any one given process. So the idea of building them with multiple chips was a great idea, but getting a means to interconnect those chips has always been a challenge and difficult. Flip chips has been one that's been around for going on 50 plus years that now seems to be getting some better support in this technology. The current, it seems like every 10 years we change the name of the technology. The current one is heterogeneous. Well, we do that in order to get, present it as a new technology and get people re-excited about it.
Good marketing.
Exactly. Anyway, the current one is heterogeneous assemblies, and it was at one time as multi-chip modules, another time as 3D. We use hybrids, but the idea is to try to have minimally packaged semiconductors. The last company that I did, we called them chip scale packages, and enable them to be attached to substrates that are compatible, generally silicon substrates or glass substrates, And then from that, you can create, sort of a subsystem that's smaller than what it would be, and using the conventional surface mount and through-hole parts. So Chicklets has become a means that the semiconductor companies are using to try to create second sources for the more common chips. And again, just like you're finding with these funny BGA type packages, the different semiconductor companies are fighting tooth and nail, because in the semiconductor world, the smaller you can make the chip, the more money you make, because the idea is to squeeze more chips on a wafer, because you only got a limited size wafer. So the more you can put on there. So the closer they can put pads together, the screwier places they can put pads, the better. But that doesn't, bode well for you on the assembly side, because you want to have, pitches and lead frames and gull leads and the like, and ball pitches that are readily mountable. Anyway, Chicklets has become the term that is being bantered about within the equivalent of the old IPC is called SEMI. They're the standards organization on the semiconductor side. Anyway, SEMI keeps driving the idea of having chiplet standards. And you're right, the term chiplet comes from Chicklets, because my last company, Chipscale Inc., I decided we needed to promote this idea of wafer level packaging as a concept. That's where our patents come from. And the idea of chip scale packaging. And you're going to laugh this. I really shouldn't tell this story. My grandmother, in order to convince me not to chew gum, told me that the Chicklets that she loved came from Indians in the Amazon, and therefore were not particularly healthy for us.
There's always
Did it work?
something you tell the kids to try.
Exactly.
Yeah. I don't know if this applies, because I'm trying to picture this in my head, but I did a project for Wayne State University. One of the students there came to me, and he had this crazy PCB design going on. He just wanted to test this theory out. He had a height issue on the board that he was building, to the point where he couldn't use the actual D-pack because it was so high. He took the die out of it and then wanted me to solder to it, right? Is that kind of like what this is, where they just...
Yeah, that's the flip chip. Yeah.
Okay.
Yeah,
because it was... it's difficult to solder that stuff. It's not easy.
Well,
Yeah,
the
so that's a
metallization
pretty
is
fine
because it's
wire.
well, it's basically aluminum, or maybe if you're lucky, you had some gold on the pad. But yeah, it's just not compatible with solder. We also have used gold studs, where we put the gold wire has both a ball when it joins to the chip, and then a tail when it joins to the lead frame. If you basically snip the wire where it comes out of the ball, you can create a little stud. And being that that's gold, if you use a type of solder, usually a bismuth bearing solder, you can actually solder that directly to the board without having the gold get completely consumed by the solder.
That kind of like a precursor to copper pillars?
Yes, exactly. Yeah, exactly.
I was able to get a couple to flow. I forget what I did now. Elias, do you remember that?
Pre-tin them, probably. You must have
No.
pre-tinned them somehow.
No, I don't know what I did.
There was probably a
remember-
toothpick involved.
Don't knock that. They always make fun of me, Phil, for the toothpick. Yeah, I'm really good with placing solder paste down with a toothpick. I got a steady
There's the
hand,
toothpick, yeah.
and I can see through the microscope screen pretty good. So, hey, mission
Hey,
accomplished.
if it works, don't knock
There you
it,
go,
Cripes.
right? Yeah.
Yeah. Exactly.
Don't be calling me for your services, Elias, when you
Yeah.
need my.
I'd be the last person to besmirch you for that type of innovation. Yeah.
So Phil, you were around at the onset of the SMT and saw people trying to reject that as a technology, or rough adoption of it at first, for sure. And then we've all heard of quotes like I think it was Clifford Stoll said, "This internet thing is just a trend, isn't going to stick around." How many other things like that have you seen in your career where something that's still around today didn't seem like it was going to make it as a technology?
Well, as a real youngster, just freshly graduating from undergraduate school, I interviewed a company in Lynchburg, Virginia called GE. And here I was. I had the benefit, the pleasure of being in one of the very first semiconductor companies in bachelor level program in the United States. University of Florida was one, and I think Illinois was the only other one. So anyway, we were getting recruited by a number of companies, and I was invited to go interview in this place, Lynchburg, Virginia. And they were making these things called hybrid circuits. And I was very proud to start to talk to him about these newfangled semiconductors. And he said, what kind of yields do you get on these things? Well, I mean, even today, if you can get 20% yield on a wafer for some of these semiconductors you're celebrating. I mean, NVIDIA, cripes, if they get 4% yield, they go out and party like crazy. Anyway, I think I mentioned to this guy, he was the general manager, that, maybe on a good day we'd get about 20%. He said, well, on my parts, I get 98%. So it's obvious these things are never going to make it. So that's one.
Yeah, for sure.
That's a big one.
And then, of course, then there was the surface mount one, and then the other one. Well, chip scale packaging. That's still one of those things that's basically waiting to happen. With that company, we came up with a means of literally protecting the chip on the wafer, fully packaging it with not only terminations that were compliant with coefficient of thermal expansion, but it turned out they were hermetically sealed. Motorola bought all the rights to our patents because we could make the world's smallest fully encapsulated hermetic transistor. But even today, I mean, you seldom hear of the only place where the chip scale parts have become mass marketed is actually in the camera modules that are in virtually every cell phone in the world. So, I mean, I can sit here and say that I have my name is plastered somewhere on the licenses with virtually every cell phone manufacturer in the world for the patents we came up with. Now,
Sweet.
can I say that I have checks to go along with that? No. Can I say that I had the joy? Well, can I say that I had the joy as an engineer to learn about the legal system and spend 5 years in 5 years in litigation and 2 years on a federal creditors committee? Yes, I can say that too.
Yeah.
Things they don't tell you in
experience.
engineering school. So.
I don't know why, but I get flashed to that scene, and I don't know if it's at the end of Anchorman 1 or the beginning of Anchorman 2, when he gets offered that job from ESPN, and it doesn't exist yet, right? And they're like, we're going to create a network where we just talk about sports all day long, and he's like, that's the stupidest thing I've ever heard.
That will never work. Packaging is nuts, though. The scale of what's happening inside of these components and how they get manufactured, like to have been a part of some of that, seeing the start of SO packages and the like. I mean, Sean, like you think about what we complain about as assemblers, but all the packages we work on, we're working on the outside. It's already constructed. Think about the architecture within all of those tiny little packages we're complaining about, and they've somehow built working components inside of the, I mean, it's insane.
Even the fact that he talks about like the pad landing dimension is already defined for us. Like, because that's what my program was comparing it to, was like, hey, the IPC spec for this pad on this part is this, right? Like that's all there, like he can't just whimsical, create up his own whatever he wants for that lead, which he did in theory, right? But like, I now have a system where I can say, hey, this is going to give me, and what was, I even have the proof of the picture from the AOI of what happened when he ran it that way, right?
Well, and if you look at a lot of these, packages now, if you put them under an X-ray, you're like, this isn't assembly. This is its own assembly. and that's
Yeah.
what they're running on a board. There's so much crammed inside of them. It's pretty incredible.
Right, right. Yeah, that's where the multi-chip modules come in. Yeah, exactly. Well, as a point of pride, I mean, one of the other things, I mean, here I started 3 companies, and then, as part of a couple of large corporations, the last one being Signetics, which became Philips. And I'm sure any of you that are owners of small businesses realize that there's just a lot of friction that develops within the teams of small companies, and so
Mhm.
a lot of times you sacrifice the personal relationships when you have small companies. I mean, as a point of pride, this morning I held a meeting that I helped put together. We do it every month to 2 months. There were 12 of us on the line. I mean, these are the guys that over 50 years ago, I mean, we go back, like I joined Signetics in 1976. These other guys, like the one fellow mentioned, he had joined in 1971. I mean, these were the guys that signed the agreements and ran the processes that created the packaging wherewithal for the surface mount parts. And it's interesting to me that, with the startups that I did, I have very few contacts with the people that I worked with in those startups. There just wasn't longevity, possibly because being in a management position and not being a necessarily nice guy at the time, that had something to do with it. But anyway, here we go back 50, 60 years with these other guys. I mean, collectively, out of this group that gets together every couple of months, there's 35 of us. And it all got started because this one fellow, Mike Crawley, who's the guy that literally brought over the part that became the SOIC, when his wife passed away, we all got concerned that what's going to happen to Mike, and so this also coincided with COVID, and so we started holding Zoom meetings, and we've been
Yeah.
holding these Zoom meetings since 2020. And it's amazing the stories that some of them are old timer stories, and some of them are new timer stories. So pretty interesting group of individuals.
I read it somewhere when getting ready for this talk that you were involved in laser trimmed IC devices. Can
Oh
you
yeah, yeah.
explain that some?
Okay. That was with I was recruited from here to go to work for Analog Devices back in Massachusetts. And they had pioneered a method by which they could trim, they could deposit using thin film metallization, the shapes of resistors onto parts of silicon. And
Mm.
then they came up with a means, working with Teradyne, to develop a laser that would go in and trim the resistors so everything was matched down to a Nat's eyeball. For in this case, we developed a 12-bit digital to analog converter. So yeah, that was that effort. And then when I was invited to leave there and come back to California, thankfully, the laser technology came with us to Signetics, and then ultimately accompany precision monolithics and laser linear technology, which I think all at this point have all got gobbled up by Analog Devices again.
It's crazy because I mean, Sean was talking about how things you've been a part of are a part of everything we're still doing today. And one of our job, like the ceramic that I've worked on in the past, we would actually screen print the layers on it and build up the board from a bare ceramic substrate, and one of them would have resistors that would go to get laser trimmed and get perfectly, the printing process wasn't exact enough for the values they needed, and go get and the embedded resistors within one of the layers would go get laser trimmed. And it's kind of wild to be talking to somebody who was involved in some of those efforts.
Although I have to share with you a story that I was reminded of last week, that there was part of me that said, I don't want to bring this laser technology back here, because Signetics hired me from Analog Devices, and at the time I was very much into sailing, and 1976 was when they had the bicentennial, and all the tall ships were coming into Boston Harbor. And the fellow that I sailed with, we had a pole position to greet all the tall ships. And the guy that hired me out here said, "I need you out here right away. We got to get this going right away. So get out here right away." So I had to, hang up the idea of sitting there bobbing around in Boston Harbor to greet the tall ships.
Yeah.
And of course, by the time I get out here, he says, "Oh, we figured out a way around that problem. So we didn't need you to come out this fast."
Wow.
So at that point, I'm thinking, why do I want to share this stuff with these guys? So just last week, where do the tall ships come into? They come into Boston Harbor again. So.
And you're in California still.
And I'm in California. That's right.
Well,
bobbing around in a dinky little kayak.
I know, speaking for myself, I've enjoyed this immensely, and I could probably keep asking a bunch more, but is there anything else that you want to talk about, Phil, before we let you go?
Oh yeah, I have one more cause de celeb that I've been starting to promote, and
Sure.
with the reality that AI is going to affect some companies to diminish the size of their workforces. Teams of engineers and your customers, the designers, have had some pleasure in being able to find somebody within a large group of responsible individuals to pass the buck to when things go wrong. With the advent of the streamlining that's occurring in certain job areas with AI, those teams are going away. So therefore, the ability to pass the buck and blame somebody else is going away. So, matter of fact, I gave a presentation at University of Florida last month where I said, one of the things you should consider starting to teach your engineers now is empathy, because they're going to have to learn that they're going to have to be more empathetic with the teams of suppliers and people that they work with, because they're not going to have that many people they can blame and walk away from and get away with it, because those scathing comments are going to stick with them. So empathy is my other cause.
I think we could all use a little bit more empathy. There's always somebody pointing fingers at somebody in this space, right?
Yeah. So
that's why I go to therapy, is to get. I picked her brain one day. I was like, "Am I a sociopath?" And she was like, "No, you're not." I was like, "All right, cool." Just kind of like
that's what they always tell sociopaths.
As she was exiting out of the room gracefully.
Yeah.
Literally the other week, though, I said something to her that must have stuck with, because she actually texted my cell phone on Sunday about how I was like, well, that's being kind of disassociative to what that person's feeling by saying that. I'm not gonna get to the whole thing. And it stuck with her head, and I'm like, man, I got in her head kind of like a sociopath would. And I maybe start thinking about myself again.
Better trip. Yeah. Anyway, as a final parting gesture, I want to compliment you guys on your effort. I think this is so beneficial for the industry as a whole, and I know it's probably going to get tiresome and rough, but stick with it. This is a huge benefit.
We're all, trust me, Phil, we're all there. We're just kind of.
But thank you.
Conversations like this, am I wrong, guys? Like, this is brings the spark back in.
Yeah, thank you so much for your time, Phil, and for saying that. And it really is, like, that's regenerative, right? Because at first it was so new and fun, and it did start to kind of feel like, okay, it's like anything else that we have to do now. But I feel like a kid, in a candy store, proverbially, listening to everything you had to say. And it really is an honor to have the time, this much of your time, and hear these stories.
Seriously.
And I know we probably all have a ton of admiration for what you did. And that's not hot smoke or it's lip service. We're really into what we do. And to talk to somebody who fostered and nurtured the industry into what it's become, we owe you a debt of gratitude for sure.
I was just one small cog in a bigger wheel. So But anyway, love to do it again. I have some more stories. We haven't even touched on how the DRAM modules came into existence.
Oh my
That's an
goodness.
interesting
I
story.
I
Oh my
want to get
goodness.
I want to get you, John Burke, the guy
Oh
with
Gene.
the
yeah,
big. Who's the guy with the big
Gene.
head on LinkedIn? Gene, yeah, but who's the big head?
Oh, Gene Weiner. Yeah,
Bob
Gene Weiner.
Willis with the
Bob. Yeah,
I
Bob.
want to
Yeah,
get
Bob. I convinced. I badgered him to bring his database out of mothball, and because I was involved with this company, Darwin AI, and they spent they spent 4 years building the database. I mean, much of it just to profile a stupid solder joint. You have no idea how difficult it is to teach a solder joint to be AI compliant. Anyway, they came up with they decided to they had the software for AI, but they didn't have a product. They decided to attach it to an AOI machine, and then Mike Buteau put them in touch with me to help be their advisor to try to figure out how to get to that market. And we just built this massive database, and they had some military customers and a medical customer, and then lo and behold, some fairly well little company named Apple comes along and acquires them. That was one of the more interesting resignation letters I received, saying, "Here, you need to sign your resignation." I said, "But guys, I work for you for free. You don't owe me anything." And they
No,
said, "No, no,
I
no. You got to resign." So I signed it. And anyway, part of the deal was Apple wanted their database. And I said, "Guys, you gotta separate this database. This thing is it's as valuable as the IPC 782 and the workmanship criteria." Wouldn't do it. So anyway, I called Bob Willis and I said, "You got the database." He says, "All I got is tens of thousands of photos." I said, "Well, I got folks that'll help digitize that, and then we can come up with a database to provide the industry for common AOI usage."
Yeah.
Anyway, he's come back out of retirement, and I'm delighted. Yeah, he's a kick.
Yeah, he's great. We talked to him before too. But I just have to, you were so kind to compliment us, and I can't let this go without saying you brought up Gene's name. You and Gene are such an inspiration to be like, you mentioned how it's like crazy to me that you two at your ages are like still pioneering and still trying to bring along the industry to the next thing. And you guys are both huge proponents of AI and how to use it. And
it's crazy.
Gene is as plugged in as anyone in the industry is on what's going on with laminates and substrates and components and everything.
Oh yeah,
I find it
Gene's
super.
Because
Gene's a
it's
wonder.
just huge inspiration.
A lot of older people will talk the talk, right? Or like, I mean, talk about it, but you guys actually still live it, like it's unbelievable to me. It's because at some point, I don't know, I feel like I would just be like, you know what, I'm gonna go fishing today and that's my day, right? And I don't care what's going on with your solder joint. I don't care about the thinness of your trace and how many ounces of copper you wanted on that thing. I just don't, and you guys just keep pushing, it's amazing. It really is.
Well,
I
our
think
desire,
it's your generation. I really do.
I mean, I know Gene's the same way. Our desire is to try to encourage, other younger folks and bring on a whole new generation to keep this thing going. Because, I mean, we've just scratched the surface on innovation. There's so much more.
Which is crazy to think. Like, I mean, if you look
It is
at
crazy
the last 30, 40 years, and if that pace even gets anywhere close to continuing or goes faster, what are we going to have?
Hard to imagine.
Well, I intend to stick around to find out. So
Nice.
And I hope you guys do as well.
Well,
That's the plan.
Well, thank you again so much, Phil, and to our listening audience. We just want to remind you, SMTAI is coming up in October of this year, the 27th through the 29th, and we will be there conducting interviews, hopefully anywhere near as good as this one. We'll be in booth 2413, so make your travel arrangements and be sure to stop by and see us. And on behalf of Sean, Daniel, producer Paul, thank you so much for being here, Phil, and thank you for all our listeners for tuning in, and we'll see you next time.
Thank you very much. Yep.